In this video, we're going to highlight power, load, and ground for the 4 circuits that make up this schematic. Since we've already learned about the pull-in winding and the hold-in winding, we're just going to highlight the schematic as if all of the switches are closed. We're starting the car, we're in the start position, the car is in park or neutral, so this switch would be closed, and we're getting power to the S terminal, and it's already given power to the motor, and it's already pulled this switch over. So let's start with the information circuit over here. Now in the last video we said that there was a resistor in here and that power, load, and ground is being used just to decide if this switch is in the start position. So if we were highlighting this as if the circuit was active, the load in green, we're going to use the same colors we've used in earlier videos, where orange signifies that there's 12 volts, green signifies a load when it's using up the voltage, and yellow will signify that there's a ground path there. So if I color in green this load that's inside the PCM, yellow would be the ground path, which would be from the bottom of the load down to this ground. And when this switch is closed, the power would be everything from the top of this resistor that's inside the PCM all the way up to B plus here, which stands for battery positive. So that's the information circuit that's used for the PCM to know if we're turning the key to the start position. The second circuit we're going to do is the relay coil, which is controlled by the PCM by grounding this switch here to allow there to be a ground path for the coil, which will then activate the relay. So the load in this circuit is the relay coil. And then when the PCM does close this switch, the ground path would be from the coil all the way down. So we would highlight that in yellow. And everything above the relay coil would be in orange, and that would go all the way back to this location here where it says there's power being supplied here when the car is in either run or start. So when the ignition switch is in the run or start position, there's power being supplied here. And notice that the ignition switch is over here, and they're only showing us the wires for the information circuit. There are other wires in this ignition switch that the output of one of them could be going to this location here to supply power. They're just not showing it in this schematic. They're just using this as the power, and they just wanted to let you know that there is power there when the ignition is in run or start. The third circuit would be the circuit that supplies power to the starter solenoid. And if we had our hold-in winding here as the load, we would color that in green, and in yellow would be the ground path, and orange would go all the way back through the closed switch of the relay all the way back to the power source. And the fourth circuit would be the starter motor circuit. When this switch is closed, power goes from the battery through the switch that's closed and powers up the starter motor. So if I highlighted the load in green, and I do the load first when I'm highlighting a working circuit because it's just easier to figure out where you need to color orange and where you need to color yellow if you start at the working load. So if I color the motor in green, then yellow would be everything from the motor down to the ground path, and orange would be everything from the motor back to the battery, which in this case is this way over here. So if you printed out this schematic on your own and you were able to highlight this, you are well on your way to understanding starter schematics for just about any vehicle, because they'll just add maybe an additional relay. They'll draw it a little different on the picture. The symbols may be different looking, but the way it works and what you'll have to recognize will be similar. In the next video, we'll do our first case study where we use the schematic to diagnose a no-start condition.